And this is going. Did I bring my book? If I didn't bring my book, I'll need to look here. I did not. Yeah.
Oh, yeah, our life group studies.
Oh, really?
Yeah.
Who leads this?
Angela Cassidy.
Okay, fascinating.
Yeah.
This is the Tuesday Nazarene.
Yep.
Differential equations will be 40. Calculus 1 will be 150.
Oh my gosh.
Think of the unit path.
That's a lot more test to grade.
You have to like pull all the names. You don't have to like take attendance.
That's a lot of names to put in a name.
Yeah, that's going to be the challenge.
It's a lot of plus C's you gotta write down.
No.
You get TAs.
No, I have teaching assistants.
Yeah, you get TAs, you don't have to do this.
You're just gonna get less work now.
What?
You're gonna get less work now.
Oh, yeah, it's less work. Absolutely. I talked to someone else who came from a school like this and went there, and they're like,
What courses are you gonna teach?
I don't know.
You don't know
Some
yet?
sort of calculus, some sort of mid-level, and some sort of upper level. I don't know what. Yes. Oh, sorry. Which one? Which one did you say was the
What
hard
was
one?
the last one? 40. What was the last one?
Oh, yeah. I see cubic.
I think it's 43.
Yeah, it's 43. I'll get it. There's a cubic.
He's giving me. Because.
Okay.
No. What about the one that has S with it? You leave it. Don't leave it. It's so small.
Oh, it is cosine.
Leave it. There you go. Thank you.
What is it? One of the things not this. Okay, well, we still have it. Yes.
Oh, on the this what?
We solved it.
That's part of this.
8 and H before and then
Is that what it is? Okay.
I walk into that room and all my knowledge leaves my head.
Yes, we want to substitute.
All right, you're almost done, Joshua.
That's all.
I'm waiting for you.
Oh, yeah.
I figured when you're done, then because you like to make sure it's perfect.
Right.
Yeah.
That's why he does better in physics.
So yeah, I don't want to jump the gun. I mean, and I'm curious to see if I got it right.
I finished after the main part and I kept.
I'm gonna find out.
If I hadn't missed that last part, I would have gotten.
Well,
Oh.
What was it at 35? So less than that.
Well, it was just part B. So part B was what it's.
At least give you something before that. You put in a completely wrong number down and then doing another column on everything. You want to do about 3.5 minutes. I'll make that.
I mean, take off the 14. Honestly, the first one was the last problem. Yeah, that was it. It completely expanded. Like, if I hadn't had that, I would have had 90.
Well, you have a problem with like 35.
Yeah. literally, I need to be crazy.
Well, you know, C is, so if you have, if you fill out C is then 0.
Okay.
S. And then B plus A is 1.
Oh, yeah, yes squared
Yeah,
plus
but
yes.
there's no S on the other side.
There's no S.
Right, so C is 0.
But then, so then A squared plus B squared.
So then you just move the S squared over the side, so that equals B.
Well, the S squares cancel to do plus B is a little.
So yeah, I could plug in 1 4 for A and S squared on the other side, so that S squared.
Or you
Yes.
could just say that A plus B is 0.
It's the same. We're getting there. We're getting there.
Come on, you almost got it. You can do it. Wait, you're done? You're done, Max? Max has it. Come on, people. What's wrong?
Your cufflinks is
Oh, sorry. I got to start watching basketball.
Yeah.
Although I found out that they didn't do so well. So then I thought, what's the point? But then I realized I could watch football.
And I mean,
Because
they'll
Bill
still be
Belichick. Is,
Yeah, I don't think Bill Belichick is a great NFL coach, but I don't think he's going to be great for college football. And he's not built for college football.
they're paying him $10 million.
I think we're paying him a lot, but he's got to win.
Okay. I thought that the money just ensured the win would come. Oh.
I mean, rated quarterback rating.
I mean, aren't they pro teams? Like OSU is a pro team now, right? Because they pay the players, don't they?
That's NIL. It's like all schools.
Yeah, so that everyone's pro.
Oh, you're right.
Technically the players are paid.
In a way.
So
I mean, but like, if we're like in like college football programs, UNC is like a bottom level.
Say OSU makes enough money that the football team can't be considered.
Unfortunately.
well,
Oh, look,
not that I don't care. That's the thing.
blind.
Okay, we're ready. We're ready. Josh is ready.
Josh is good.
Let's do this. Let's see if I got it right. Okay, so let's find out. So here's my first move. Is I switched over to the Laplace transform. Did I do that one right? Top line. Yes, you're checking me, Josh.
I think so.
Top line look good.
Yeah.
Okay. Then you collect like terms and solve for y of s. And you get this. Still look good? So far, so good. As you can see, I skipped steps because you know me, Mr. Step Skipper. Okay, so then I did this. Once again, skipping the steps, right? Doing the partial fractions in my head. And it's like a magic trick, but is it right? No, it's not right. Oh, no, I think it's right.
I think so. Yeah, these
I didn't combine these. I was like, I'm not
Right.
gonna,
Yes.
I think you were commenting on this, don't combine these,
That was
just,
wrong.
just leave this, I just did this. Just this.
No, B is negative.
Yeah, B is negative 1/4,
Yes.
and C is 0.
Yes.
Oh, yeah, it is.
Yeah, negative 1, so you got A, B, and C. Okay, so I'm good still? Okay, and then we do the inverse Laplace. So this is two separate ones. So this is going to be cosine and sine. The one with the S is cosine, the one with the number is sine. So then we got this. Oh, that's it, right? Yeah, that's it. Wait, what's this down here? I don't know what that is. Oh, that's simplification. I combined the cosines. What's that? I got it right? Okay, I got it right. All right, let's do this. We're done? We're done. What do I have down here? Oh, number 41, that's right. It's like, what am I? Yeah, you made me do number 41. Okay, so any other questions about the quiz? Did you get 100? Okay, good. So I'll mark you all down. No, you corrected it though, right? Okay, then yeah, put 100 at the top. There, put 100 A+. There you go. Mark it down. Put a check mark. Put a smiley face. Do whatever it takes to make yourself feel better. Okay. So number 41. Someone said number 41 was the best, so I thought we got to do the best. That's not the right one? It is the right one. Let's do the right one.
It's 43, but that's the right problem.
Oh, sorry. This is 43. Okay, 43. All right, let's crank this out. Fortunately for us, most of these are zeros. That's a 1 down there. So we're going to have to deal with that with this y triple prime. But the rest of it should be pretty straightforward. So the way that this is going to shake out is you're going to have, let's see, 2, let's see if I can get this right, times s cubed times y of s minus 1. Hold on a sec. There it is. Okay, so that's the, times minus 2. Okay, so there's that. S squared. Sorry, I've got it. This is crammed in here. Let me fix this. Hold on a second. Okay, times y of s. So far, so good. Then minus, let's see, 3s times y of s minus 2 times y of s is equal to 1 over s plus 1. Oh, and you're using, yeah, so if you don't have it memorized yet, there's the table. The table is on your test, so don't worry. You don't have it memorized yet. You might have it memorized by the time we get done with all this, but yeah, so it's fun. Okay, so let's factor this out. So we've got 2s cubed. Oh, and by the way, the reason why we only have that there is because the only initial condition that was non-zero is this one right here. So the only one that had anything going on with it was the y triple prime. The rest of them, you have a bunch of zeros for the initial conditions. Okay, so let's see, 2s cubed. Give me a sec here. It's going to take a sec to write this down. 3s minus 2. That's the cubic. 1 over s plus 1. Let's see, plus 2. Okay, well, You know what? On this side, give me a sec here. Let me just do this real quick. This is going to be 2s plus 3 over s plus 1, just because it'll save us a little bit of time. Not much, marginally, a little bit of time. Okay, so then we've got y of s is equal to all of this. I see s squared squared minus 3s. Okay, so how do we factor that? All right, well, you remember synthetic division? It's an option, isn't it? Okay, we don't have to do synthetic division if you don't want to. We can, but here's the thing. Here's the thing about this is that to factor this, if this factors, those are the two numbers that matter. Is the 2 and the -2 there. And so the only factors that are possible are factors like this: x plus 1, x minus 1, 2x plus 1, 2. I'll write them all down. There's only a few. I'm almost done. So these are the possible factors. So these are possible factors. And then x minus 2 and x plus 2. That's it. Those are the only possible factors. Because if this has factors, the coefficient of x will be a factor of that number there, the 2 there, the front 2. Here, maybe I should highlight. So this is like a pre-calculus type thing, but I know you guys are all super advanced students, and so you had pre-calculus back in 7th grade. So it's understandable. It's been a while. So so when you're factoring this number here, the coefficient of x, so the coefficient of x will be it's not x, these are s's. Sorry, I'm used to x's. So these are s's. Sorry about that. But anyway, the coefficient of the x or s or whatever it is will be a factor of that number, and the constant will be a factor of this number. That's just the way it is. When I forget, it's been so long since I've taught pre-calculus. I can't think of the mathematician whose name is this is a rule. This is one of these rules you learn. No, it's not. But yeah, maybe you can call it that since you learned it from me, but whatever. So these are the possible factors. So now here's the deal is when you're doing synthetic division, essentially what you're doing is you're saying, does this number work here? And so you basically are going to pick one of these and see if it works. So let's try this one. Let's try that one. See if that one works. Is that a factor? In synthetic division, what it does, here's what it's really cool. Synthetic division actually plugs in the solution x minus 1 and sees if you get 0. And if you get 0, then it's a factor. So if you don't want to learn synthetic division again, you can always just take that, plug it into this, and see if it works. Let's see. Does it work? Well, s equals 1. So here, I'll write this down here. 2s cubed plus 3s squared minus 3s minus 2. Does s equal 1? Does that make that equal to 0? It does. Well, then that's a factor. So now we've got one factor. The rest of them are going to be easy. So s minus 1. So let's see. What's the s? Now I actually have to do synthetic division. So s times 2s squared equals 2s cubed. Then I take s, or negative 1 times 2s squared is negative 2s cubed. So I need an additional 5s cubed to make 3s squared, or sorry, 5s. So I'm basically doing synthetic division here. This is going to be plus 2. I think that balances out. Yeah, you can double check, but I think that does it. And so now let's see which of these other factors are going to work. S plus 1, s minus 1. Let's see, how about 2s plus 1 and s plus 2? Does that do it? Yeah, that does it. So they're there. What's the big deal? Oh, actually, I see the big deal. Now I have to actually do the partial fractions. Really? Oh, factoring cubics, yeah. Yeah, sometimes, now the reason I said, that's the worst case scenario, actually, what we just did. Much better case, so if you're doing something like this, minus x squared plus 2x minus 2. So do you know how to factor that? Yeah, factor by grouping. So once the reason why you can sort of see that this groups well is because you can kind of see that there's whoa, come back. What just happened? I don't know why that happened. So you can do x squared times x minus 1 plus 2 times x minus 1. So sometimes you can group. You know what? Oh, could I have grouped this? Oh, yeah, yeah. Well, I was wondering if I could group these two, but that doesn't really work. Yeah. Sadly. Yeah, so I think that doing this, which is essentially what I just did with synthetic division, that's the best case scenario. Okay, yeah, so there it is. And then you can use Desmos. That's another way. Is that what you ended up doing?
No, I mean, I
Yeah.
solved it, but
Oh, you just suffered?
like for the partial fractions.
Yeah.
Yeah, the partial fractions was not as big.
Okay. What is this? This isn't what we want.
Just did it plug into it.
All right, so the rest of it is, yeah, and once you have this, and once you have all of these, you know that those factors are going to produce exponential functions. So like this is going to be e to the negative 2t, e to the t, e to the negative t, and this is e to the negative 1/2 t. So you got a bunch of exponentials. So we don't need to do more of this. I'm happy not to do anymore.
There's no cubics on the exam.
I don't think so, but let me check. I've got the exam right here. Where is it? Not there. Where's my exam? Oh, no, that's I've got the stats exam. Hold on a minute. Let me see if I can get the, yeah, okay, I can show you that. That's fine. That's 3. Where did I put? Is this it? Oh yeah, here it is. Yeah, I found it. I'll zoom. Let me show you. I can't see the whole thing. Hold on a minute. Scroll. There we go. Okay, here it is. So you can see the whole thing. Why can't I? What do I do? Oh, there it is. What's going on? Oh, yeah. Okay, yeah. So you can see that you got a bunch of, these are just basic differential equations up here. Laplace transforms are all on these 2 pages. So you have just a few. There's some basic doing one way and then doing the inverse Laplace, and then these are differential equations. And then these, I forget, oh, spring mass systems, I believe. That's a spring mass system. I don't know what that is. I guess I can figure it out. Initial value problem. Let's see. Come back here. Yeah, let's see. Yeah, I'll check though. I'll actually zoom in here and see if there's any cubics. I don't think there are. Why would I do that to you on an exam? So let's see. The highest, okay, the worst case scenario is second derivative. Yeah, and actually, all of these, the ones that I say use Laplace transforms, they're all really easy. Here, let me just show you. They're not this easy. Here's one of them. Here, I'll show you. Well, this is similar to one of them. So this is the easiest of the bunch, so don't get too excited. So let's do this. D squared y over dt squared is equal to, let's just make sure that it's at least somewhat interesting. About e to the 2t. Y prime of 0 is equal to 1. How about that? Can we do that? I know. Yeah, the reason this one's so easy is because this one you could do without Laplace transforms, right? So anyway, you can always check your work. But yeah, this one is super easy. It's here. I'll even do it right now. It's going to be s squared times y of s minus. Let's see. This is going to be let's see. Minus 1 is equal to 1 over s minus 2. Is that right? Did I do all of my stuff here? So you can check on your thing here. And then we're going to just do this. Y of s is equal to 1 over s minus 2 plus 1 over squared. Oh, this one actually, this one is a little bit harder than the one on the test because you have that s squared there. But it's not terrible because you have to do partial fractions with this. But it's not a terrible partial fraction. So let's see, y of s. Let's see if we can do this without squared. So you've got s squared, s, and s minus 2. So what do we need to do here to make this work out? Okay, so this is going to have to be -1/2. And then, yeah, I might not be able to do this one in my head. The reason being that you're going to multiply that by s minus 2. That'll give you a -1/2 s. Yeah, this is going to be harder to do in my head. Anyway, it's something like this. It's not a terrible one. You do your A, B, and C and figure it out. And then, of course, this will be t. That'll be 1/2 t. This will be just a constant, and that's going to be your e to the 2. Yeah, so this one's actually a little bit harder than the one on. And then there's a couple of others on the test. Here's one. Here's another one that's similar to what's on the test. Y prime is equal to cosine of t. Y of 0 is equal to 3. I know. Like, once again, you didn't really need, this is like Calc 1. But yeah, so you could do this one, of course. This is just going to be s times y of s minus 3 is s over s squared plus 1. So this is going to be y of s. It's s over s squared plus 1 times s. Ooh, those cancel. Oh, brilliant. Okay. Oh, no, that's so beautiful. And then plus 3 over s. So this is super easy. So y, I hope it's this easy on the test, is sine of t plus 3. Done. Wow, that was super easy. So, yeah. Let's see, is the one on the test that easy? I think it is. It's not the same problem. Oh, there's one that's like that. There's another one that's a nightmare, but I'm just saying that there's some good ones. There's some easy ones.
Do we get like the Y of S formula?
What do you mean?
Like you get on the quiz?
Oh, yeah. This is right there. Yeah, I'll show it to you. Let me see. Can I show it to you? Oh, yeah, here it is. Here, just a minute. Yeah, this is the actual test. Let's see. Can I bring it over? Look at that. Yeah, actual test. Oh, don't look at that. There you go. So you've got, Laplace transforms, and over here, more Laplace transforms. So, yeah, they're there. And look, even here.
That's what.
Oh, these here. Oh, and you have something we haven't even covered yet. Oh, and I didn't bring my hammer today. I meant to bring a hammer because we're going to, on Monday, after the break, we're going to use the hammer to demonstrate discontinuous forcing functions. So if you imagine my spring, and if I take a hammer and hit the spring with the hammer, there's a discontinuity that I'm introducing into the forcing function. That's what this is. So these are discontinuities. But they're on there even though they're not on your test, but they're there. So you can ignore this. When you look at those, you're like, what is that? Ignore it. Ignore those. So that's on your test. So ignore them. All right, anything else? Other worries about the homework or about the test? Oh, practice test. I didn't even get to that. Sorry. Did anyone look at a practice test? Do we have a practice test? Yeah, you couldn't tell me. He doesn't care. Yeah, you'll care. Okay, let me just peek. Let me make sure you've got a practice test to look at. Yeah, I remember what I did here. So you have a couple of them. I've got the 2020, which is the coronavirus. And so that was the take-home thing. So you can ignore this up here. I just put that there because I wanted to show the students that year what they were in for in terms of what they're going to sign for me. On your test, we didn't have tables like this, so you won't have that. So yeah, let's just go through this really quick. So that, and if you're confused, I know some of you are going to be like at home and you're going to be like, wait a minute, is there going to be something like this? No. This table on your test, even though it's kind of cool, basically just classifying these different spring mass systems as being underdamped, overdamped, or whatever, and finding their natural frequency. Natural frequency being how fast is the thing going up and down. And then, okay, so that's fine. We're not going to have that. But you will have stuff like this. You will have to do the integral definition of Laplace to compute something. Let's see. So all of this is good. Yeah, one by hand, just one. Okay, yeah, all of this is good. And I felt bad. So just so you know, I got done with that and I realized, I need to have at least some more. So I have another practice test. It looks similar. There's probably some overlap. Wait, is this exactly the same? No. Oh, I know. Yeah, this has more spring mass system stuff. Yeah, so here's a spring mass system. More differential equations. So this one just has more practice. Oh, wow, this is long. But I pulled it out of my files. So as you can, whoops, I didn't mean to do that. Here we go. So the sample and then the answers I hope are correct. I wrote these up 3 years ago or 4 years ago, so don't yell at me if I'm wrong. Or if I am wrong, just let me know. Look at them, they're beautiful. So you can look those over and let me know if you do find anything weird. I'm happy to either correct them or just tell you you're right and I'm wrong. So any other worries? Okay, so if anyone isn't gone, I guess I got confused. I thought that the volleyball players were going to be gone. Are they going to be gone Friday as well? No, we don't know. Well, I brought Proctor request forms, so if you're going to take this in the testing center, I have that. If you want to take this at 6 a.m., let me know. I'll be here. Well, I'll be on campus probably around 6:30. So if you want to take it that early, I can be. I'll be in this room giving tests from 7:50 or 7:30 to 10:10. So if you want to do it early, you can do that as well. I think that's it. So any other questions or concerns, or are we all set for Friday? We're all set. So I'm gonna stop the recording if you want to stick around and chat. Otherwise, I hope you have a great day. Oh, I wasn't wearing my mic. Oh, well, it's just sitting here. The sound will be all muffled.